Imagine for a second that you're trying to teach a toddler about animals.
Okay.
You sit them down, you have these little flashcards, and you go, okay, see this? Floppy ears? Dog.
Right. This one's a cat.
This aloof creature judging you from across the room, that's a cat. The one stealing your french fries at the beach. Bird.
That's pretty much the classic model, yeah. Pattern recognition through, repetition.
And that is effectively what developers are doing right now with AI. They're feeding these huge systems.
Mm-hmm.
But instead of flashcards, it's just mountains of data. Text, photos, sensor readings, you name it. Also, the AI can learn patterns.
And it sounds so simple when you put it that way, right? Like you're just filling up a gas tank.
Yeah, exactly.
But this is where the real problem starts. Because unlike a generic picture of a dog, the food for these AI models, it's often made of something much more sensitive. It's made of us.
It's our data.
It's our data.
And that's the whole tension we're diving into today. The idea of training AI is straightforward, but the ingredients are just messy. We're talking about real people's private information getting tangled up in all this.
And not just tangled, but potentially exposed in new ways. So our mission for this deep dive is to really get into the weeds on the specific privacy and security hurdles.
Right.
We're not just talking about hackers. We're talking about things like model inversion attacks, the absolute alphabet soup of legal regulations, and basically the recipe for how to fix this mess.
I am so ready to see how the sausage is made here. Although, based on our sources, maybe how the neural network is knitted is a better analogy.
I'll stick with food. The ingredients part is just too perfect.
Okay, so let's start with feeding. We know it means inputting huge data sets.
Mm-hmm.
What kind of data are we actually talking about? Is it just a neat spreadsheet with a name column? Because that seems easy to fix.
Oh, if only. That's the most obvious layer, what we call PII, personal identifiable information. But in these massive training sets, the data is almost always unstructured. Think customer support chat logs, emails, free text fields in surveys.
So it's not neatly labeled at all.
Not even close. I mean, imagine a support chat where someone types, "Hi, my name is Sarah, my phone is 555-0199, and I'm calling about a prescription for my heart condition."
Oh, wow.
That's not in a database field called medical history. It's just a blob of text. And if you feed that whole log into an AI to teach it conversation,
the AI just absorbs it.
It absorbs that specific medical detail as part of the pattern it's learning. And you can't just, delete a column in Excel to fix that.
Okay, devil's advocate here. I'm a developer. I write a script. I find every string of text that looks like a phone number. I redact it. I find the names, delete them. If I delete the identifiers, aren't we safe?
You would think so. It's the intuitive answer, right? I remove the name so it's anonymous.
Yeah.
But this is where the security community starts pulling its hair out. It's called the re-identification risk.
Re-identification. That sounds like a spy movie plot.
It really feels like one. The reality is that taking out the name just isn't enough. Not anymore.
How so?
Because of all the other data we generate. There's this pivotal study that showed you can uniquely identify a specific person using a combination of just 3 things.
Wait, really? Just 3 things?
Just 3. Their zip code, their birth date, and their gender.
How is that possible? I mean, I share my zip code with thousands of people. I share my gender with, half the planet.
Mm-hmm.
And my birthday, there are only 365 days. It feels like there has to be overlap.
You'd think that, but think of it like a Venn diagram. The circle of people in your zip code is small.
Okay.
The circle of people with your exact birth date is also small. When you overlap those 3 circles, statistically, there's usually just one person standing in the middle.
So I'm a bad actor, and I have this anonymous data set from a hospital.
Exactly. You go by a voter registration roll, which is public record, and it has names, addresses, and birth dates.
Oh, no.
You just match the zip, birth date, and gender from the anonymous file to the voter roll, and suddenly you know that the patient with the heart condition is actually Sarah Smith from down the street. You've re-identified her.
That is wild.
Yeah.
It just shows that anonymous doesn't actually mean safe. It just means harder to read.
Exactly. And that leads right into another huge problem, the consent trap.
This feels like something I've definitely clicked accept on without reading.
We all have. But the trap here is about what they call purpose limitation. Let's say you download a simple flashlight app.
Okay.
But in the terms of service, it says they can collect your location data.
I've seen that. Why does a flashlight need my GPS?
It doesn't. But you consented. So now, imagine that app developer decides to pivot their business. They take 5 years of your location history, everywhere you've ever been, and they sell it to a company building an AI for traffic prediction. Or worse, surveillance.
I 100% did not agree to that.
That is inadequate consent. You agreed to data collection for one purpose, the flashlight, but it got repurposed to train a model. It's a huge violation of trust, and now it's a violation of the law.
But I can see the business owner thinking, hey, I collected this data legally. Why can't I use it to make my products better?
Because that data allows for inferences you never cleared with the user. I mean, if I have your location history, I know where you sleep, where you work, which doctors you visit.
Okay, I get it. The risk profile just explodes.
Completely.
So we've got the data itself being a total minefield. What about the tech? How does an AI actually leak this information? It's not just someone stealing a hard drives, is it?
No, although that's always a risk. But before the AI is even built, we have what's called the cloud bucket issue.
Right, and we're not talking about a bucket of water. We mean S3 buckets, Azure blobs, cloud storage.
Correct. These are basically massive folders on the internet where developers just dump raw data to get it ready for training. The problem isn't the cloud itself, it's the configuration.
The default settings problem.
It is. A developer might set a bucket to public to make it easy to transfer files, and they think, oh, I'll lock it down later.
And they forget.
They forget. And now you have hackers, or even just researchers, running scripts that do nothing but scan the internet for open buckets.
Yeah.
They aren't even hacking in the traditional sense.
Or just walking down the street trying doorknobs.
That's the perfect analogy. And if they find one open, they download terabytes of training data. The breach happens before the AI is even born.
That's just negligence. Okay, but let's say the bucket was locked. The AI is trained, it's live. Is the data safe now that it's been digested by the model?
You'd hope so. But this is where we get into the really sci-fi stuff. Model inversion and extraction attacks.
This was one of the wildest things in the source material. You have to explain how this works.
So imagine you have a customer service bot that was trained on those sensitive emails we talked about.
Okay.
An attacker doesn't need to break into the server. They just need to talk to the bot.
They just chat with it.
They query it over and over. They might ask, complete this sentence. The diagnosis for patient number 1724 is. And if the model was overtrained on that specific data, it might just spit out the answer. The diagnosis is diabetes.
It actually regurgitates the training data.
It leaks. Think about our cooking analogy. If the data are the ingredients and the AI is the finished dish.
Model inversion is like tasting the soup and going, oh, the chef used saffron.
Exactly. And not just saffron, but, saffron from this specific region harvested in 2023. A savvy taster, the attacker, can reverse engineer the secret ingredients just by analyzing the output.
That is terrifying. It's like the black box isn't actually black, it's translucent.
Right, and that's a double-edged sword. Because the stakeholders, the business leaders, often can't see what the model relied on, but an attacker can just keep prodding it until it confesses its secrets.
So we've got leaky buckets, chatty AI models, legal nightmares. All right, we have to talk about this. So what? Why should a business leader actually care about this? I mean, beyond the basic morality of it.
The moral argument should be enough, but let's be real money talks. And the stakes start with what our sources call the legal hammer.
We're talking GDPR, CCPA, the alphabet soup.
An alphabet soup with very sharp teeth. Under the EU's GDPR, the fines for this stuff aren't just a slap on the wrist. They can be up to 4% of your global annual turnover.
4% of global revenue. That's not a parking ticket. That's an extinction event for some companies.
It is. And that's just the fine. Then you have the reputational damage. If your AI leaks customer data, your brand trust just evaporates.
And in this age of AI, trust is everything.
It's the only currency that matters. If people don't trust you with their data, they won't use your tool, period.
There was another point in the research that I found really counterintuitive. We tend to think of privacy and performance as being enemies. I can make it secure or I can make it smart. Pick one. But the sources argue that privacy can actually help reliability.
Yeah, it's this privacy quality connection. Think back to those messy chat logs. If you have a ton of PII in there, random phone numbers, addresses, that's actually just noise. It's not a pattern the AI needs to learn to understand human language.
So by scrubbing the sensitive stuff, you're actually cleaning up the signal for the AI.
In many cases, yes. But it is a trade-off. If you over-scrub, say, You remove every mention of gender from a medical data set, you might hurt the AI's ability to diagnose conditions that present differently in men and women.
Right, you've sanitized it so much that there's no utility left.
Exactly. So the goal isn't just delete everything, it's smart scrubbing. You have to protect privacy without totally destroying the statistical patterns that make the AI useful.
Okay, let's pivot to solutions. We promised a recipe for fixing this. And using that cooking metaphor, the first step is clean the work area.
Which translates to anonymize your data before it ever touches the model. Don't leave those rare spices, the PII, just sitting out on the counter.
But we just established that's hard to do at scale.
It is hard. You need advanced tools like natural language processing scrubbers that can understand context. It's an investment, but it is way cheaper than a GDPR fine.
Fair point. Okay, step 2 in the recipe, lock the pantry.
Encryption. This has to be non-negotiable. Data at rest sitting on a server needs AES 256. Data in transit moving across the internet needs TLS.
I feel like everyone nods along to encryption, but the implementation can get sloppy.
It often is. People manage keys poorly, or they'll encrypt the main database but leave the backups in plain text. It has to be end-to-end.
Next up, chef-only access.
Role-based access control. Or RBAC. I mean, does the junior marketing intern really need access to raw training data full of medical records?
Probably not, no.
Exactly. They just need the finished model. Only the data scientists, the chefs, should be touching the raw ingredients. Everyone else gets the menu.
And then there was sandboxes.
Yeah, it's exactly what it sounds like. You train your models in an isolated environment, one that is not connected to the open internet.
That must create some friction for developers, right? I can hear them now. I can't download the libraries I need.
Oh, they will complain. It adds friction. But it prevents that cloud bucket problem where one little misconfiguration exposes everything. It keeps the mess contained.
Okay, and the final step in the recipe, and this one feels huge, throw away the leftovers.
This is the one most companies fail at. Once you've trained the model and you've validated it, delete the raw data.
But wait, don't you need it? What if you need to retrain the model later?
Then you keep a secured cold storage archive. You don't leave it sitting on an active server where it can be stolen. The source calls it the purge.
Make it unrecoverable.
If you don't have the data, it can't be stolen from you. It really is the ultimate security measure.
And wrapping all this up is the human element, the compliance officer.
You need someone whose entire job is just to watch the regulatory radar. These laws are constantly changing. The EU AI Act is coming. US state laws are a patchwork. If you don't have a lookout, you're going to hit an iceberg.
Wow. So we've gone from a toddler learning what a dog is to the pretty terrifying reality of re-identification and global fines.
It's quite a journey, but I think the main takeaway is that privacy isn't some feature you just sprinkle on top at the end. It has to be part of the flour. It's structural.
If you try to bake the cake without it, the whole thing just collapses.
Worse, it ends up poisoning your guests.
And for the business leaders listening, that's really the message, isn't it? Treat this data with the same care you treat your own bank account credentials.
Absolutely.
If you do that, you get all the benefits of AI, but you actually get to keep your customers and stay out of court.
Which is always a win.
It is. Before we go, I want to leave everyone with a thought that's been nagging at me since we talked about that taster reverse engineering the saffron. We interact with these black boxes every single day. Chatbots, recommendation engines, credit scoring systems. If a savvy hacker can taste the dish and figure out the secret ingredients, what does that imply about our secrets? Are we moving toward a world where the dish inevitably reveals the chef's recipe? And if so, are any of us really ready for that?
That is the billion-dollar question. And until we figure it out, we better be very, very careful about what we put in the pot.
Thanks for diving in with us.
Anytime.
See you next time on The Deep Dive.
Until next time, keep exploring, keep questioning, and keep diving deep. Thank you for listening to today's podcast. Please feel free to click on the link in the description below to discover more podcasts.